Good morning, everyone. Thank you for joining us and welcome back. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, the Science and Technology channel.
Yep, and we're talking about a good one today. We always like talking about stories that deal with health and being able to get better, and this is a good one.
Yep. A new nanoparticle vaccine successfully prevented several aggressive cancers in mice, including pancreatic and melanoma. The treatment activated strong immune memory, keeping up to 88% of vaccinated mice tumor-free and stopping cancer from spreading. By teaching the immune system to target cancer antigens, the vaccine showed long-lasting protection and broad potential. Would you like to know more?
Yeah, and pancreatic cancer? That's a death warrant, basically,
Yeah,
right?
nasty. Yep.
So yeah, this is really good news. A research team at the University of Massachusetts Amherst has shown that a nanoparticle-based vaccine can successfully prevent melanoma, pancreatic cancer, and triple-negative breast cancer in mice. Depending on the cancer type, as many as 88% of vaccinated mice remain free of tumors, depending on the cancer, and the approach reduced, and in some cases, entirely blocked the spread of cancer in the body. That is
amazing.
Yeah.
Quote, by engineering these nanoparticles to activate the immune system via multi-pathway activation that combines with cancer-specific antigens, we can prevent tumor growth with remarkable survival rates, said Prabani Atukorale, assistant professor of biomedical engineering in the Riccio College of Engineering at UMass Amherst and corresponding author on the paper.
Atukorale's Raleigh's earlier work found that her nanoparticle-based drug design could shrink or eliminate existing tumors in mice. The new results reveal that the same technology also works as a preventative strategy. Even better.
Nice.
Yeah.
In the first phase of the study, the researchers paired the nanoparticle platform with well-known melanoma peptides called an antigen, similar to how a flu shot typically contains parts of the inactivated flu virus. This combination activated T cells, which were then primed to recognize and destroy melanoma cells. 3 weeks after vaccination, the mice were challenged with melanoma.
80% of the mice given this super adjuvant nanoparticle vaccine remained tumor-free and survived for an entire 250-day study. Every mouse that received a traditional vaccine, a non-nanoparticle formulation, or no vaccine at all developed tumors, and none lived beyond 35 days.
Wow.
That's quite a contrast right there, yeah.
Yeah, and I think already mice, they don't have a long lifespan. They're pretty short lifespan.
Yeah.
The vaccine also prevented melanoma from spreading to the lungs. When the mice were systemically exposed to melanoma cells in a way that mimics metastasis, none of the nanoparticle vaccinated mice formed lung tumors, while all other mice did.
Metastasis across the board is and this is a quote, is the highest hurdle for cancer, says Atukorale. Going on with the quote, the vast majority of tumor mortality is still due to metastasis, and it almost trumps us working in difficult to reach cancers such as melanoma and pancreatic cancer.
Atukorale refers to this protection as memory immunity. That is a real advantage of immunotherapy because memory is not only sustained locally, she says, we have memory systemically, which is very important. The immune system spans the entire geography of the body.
The first round of testing used antigens designed specifically for melanoma. Developing customized antigens for every cancer type, however, often requires whole genome sequencing or advanced bioinformatics. I have no idea what any of that is. To address this challenge, the researchers conducted a second experiment using killed cancer cells from the tumor itself, known as tumor lysate or lysate. Mice vaccinated with this nanoparticle lysate formulation were then exposed to melanoma, pancreatic ductal adenocarcinoma, or triple negative breast cancer cells. Okay.
The results were striking. Tumor rejection was seen in 88% of pancreatic cancer cases, 75% of breast cancer cases, and 69% of melanoma cases. Every vaccinated mouse that remained tumor-free also resisted metastasis, which later exposed systemically to cancer cells.
Those are huge real numbers right there. 88% and 75%.
Huge.
That is
Yeah.
big. Another quote, the tumor-specific T cell responses that we were able to generate, that is really the key behind the survival benefits, says Griffin Kane, postdoctoral research associate at UMass Amherst and first author on the paper. Going on with the quote, there is really intense immune activation when you treat innate immune cells with this formulation, which triggers these cells to present antigens and prime tumor-killing T cells. This powerful T cell activation is possible because of the unique nanoparticle structure used in the vaccine. And of course, we've talked about nano stuff, right? That's very small, right?
Very small machines, yeah. Vaccines, regardless the target disease, include two main components, the antigen and the adjuvant. The antigen represents the part of the pathogen in this study, cancer cells, that teaches the immune system what to attack. The adjuvant stimulates the immune system so that it recognizes the antigen as a threat and mounts a strong response.
The Atu Corrali lab designs its vaccines to mimic how pathogens naturally alert the immune system. Effective immune activation requires several danger signals working through different pathways. Quote, in recent years, we have come to understand how important the selection of the adjuvant is because it drives the second signal that is needed for the correct priming of T and B cells. This is according to Dr. Atukurali.
Many promising adjuvants used in cancer immunotherapy do not combine well at the molecular level, similar to how oil and water separate. To address this limitation, the team created a lipid nanoparticle superadjuvant that can encapsulate and deliver two different immune-stimulating ingredients in a stable and coordinated way.
The researchers believe this nanoparticle system offers a flexible platform that could be adapted to many cancer types. They also see potential for both treatment and prevention, especially for people who face a high risk of developing cancer. This concept became the foundation for a startup launched by Atukurali and Kane called Nanovax Therapeutics. Catchy name.
Let's tell them again, Nanovax Therapeutics, in case you want to do some research. You got a family member that has cancer.
Yeah.
Nanovax Therapeutics. Quote, the real core technology that our company has been founded on is this nanoparticle and this treatment approach, says Kane. This is a platform that Prabhani developed. The startup lets us pursue these translational efforts with the ultimate goal of improving patients' lives. I love it.
Yeah, and again, this is one of those deals where we talked about many times, right? I got pancreatic cancer.
What have I got to lose?
My prognosis is not good. Yeah, sign me up. I'll be your mouse for the day or for the month or whatever. This is cool stuff. Those are big numbers.
It's right on the cusp of, it's not completely cancer-free, but it's right there.
Yeah, maybe within the next year or two, cancer will be on the downside with stuff like this. This is great. This is really great.
Very exciting. All right, folks, we'll keep a watch on this. Thank you for joining us.
See you this afternoon. Thanks.